displacement, velocity, and time graphs. This is a guide to hopefully clear up any confusion that you may have. Displacement is typically referred to as either S of t or x of t. I'm pretty sure all of our questions are in the S form, but just be aware of the x term as well, which is basically saying how does a particle or an object move with time. So in this example, it starts at rest and it goes somewhere. After 2 seconds, this is displacement. After 3 seconds, this displacement, and so on. Okay, velocity time, vt, at any time t, we'll be able to read off this graph and see how fast this object is traveling. The way we find this point is by finding the slope of the tangent of the displacement graph, okay, at that point. So to get from displacement to velocity, we need to differentiate. We need to find the slope. To get from velocity to acceleration, so seeing how fast the velocity changes with respect to time, again, need to differentiate. Okay. If we're trying to work our way up this chain, okay, we're going to need to integrate. But before we do that, just note that the velocity is therefore the derivative of the displacement, and the acceleration is the derivative of the velocity. Or we could write it as the second derivative of the displacement. Okay, dash dash, meaning differentiate twice. So if I start here with the acceleration and I want to find the velocity, I'm going to integrate the acceleration with respect to t. Okay, that'll typically, to get the velocity relationship, I'll integrate this. It'll give me something plus c, okay, and I can use some initial condition. So maybe I'll be told that initial velocity is 0, and I'll use that to find my c value. Okay, if I want to find the displacement, I'm going to be integrating the velocity with respect to t. Again, I'll get something plus a constant. I should be able to use some initial or some other condition, some values that I know about the displacement, to find that c value. Alright, so to demonstrate this idea, on the velocity time graph below, the slope of this line would be the acceleration. Okay, and say the area under this section would be the displacement between 10 and 20 seconds. Okay, key ideas to keep in mind. Okay, since we're at velocity, slope is acceleration, area is displacement. Why does it make sense for area to be displacement? Well, we've gone 10 seconds at whatever this velocity is, say it's 10 meters per second. My typical speed equals distance over time, distance equals speed times time. So I need to be multiplying, and multiplying is how I'd find the area of that rectangle with my 10 by 10. Let's clean this up a little bit. Good. Alright, so let's go on and have a look at example using these skills. So if the displacement of the particle is given by this function, s of t equals 2tq plus t, find the velocity and the acceleration. So remember, I'm given the displacement, I'm trying to find velocity, so I'm down here. I need to differentiate. I'll do that. velocity is found by the derivative of the displacement, which would equal 6t squared plus 1. Now to find the acceleration, I know that the velocity function is 6t squared plus 1. To find the acceleration, I need to differentiate again. Okay, so from here, acceleration is the derivative of velocity, our velocity function here, 12t plus 0. Okay, that's all it is, stepping between velocity and acceleration. Example 2 has a lot more space underneath it, so it must be more involved. Okay, let's have a look at this one. So a particle moves in a straight line and its acceleration can be modeled with this function. So I'll write down that straight away. The acceleration can be modeled with this function. Okay, and I'll just note where t is in seconds. How do I know it's in seconds? Because of the units of both of these, meters per second squared and meters per second. So I've used this piece of information. The initial velocity of the particle is 15 meters per second. So the initial velocity is 15. Okay, this is t equals 0. What do we need to do? Put this in a box. Find its displacement after 5 minutes. That's what I need to do. Assume that the particle starts at the origin. So the initial displacement is 0. Okay, so these are all the things that I know. I'm trying to find s of t. Well, I need to find s of 5, the displacement after 5 seconds. So the way I'm going to go about this is step 1. Find what s of t is. Okay, and step 2 will be sub in to find s of 5. So here we got the first task, finding s of t. Don't know where my acceleration function went, but I'll write it back here. So I've got acceleration, trying to find displacement. I'm going to need to take 2 steps here. I'm going to need to first get the acceleration function, integrate it to find a velocity function, and then integrate it again to find a displacement function. So I'm sure I can do that. Find s of t. So first find v of t, which is the integral of the acceleration. So my acceleration function is 3t on 2 minus 5 dt. And this should be really routine now to get 3t squared on 4 minus 5t plus c as the velocity function. Okay, remember I know that v0 is 15, so I'll sub these values in to try and find c. So put 15 on the left hand side and substitute 0 for all these t values that are there. And that with c equals 15. So my velocity function is actually 3t squared on 4 minus 5t plus 15. Okay, now that I've found the velocity function, I'll have some chance at finding the displacement. Okay, so draw a line down here. Now I'll find s of t, which I know is the integral of the velocity. Okay, the integral of 3t squared on 4 minus 5t plus 15. Again, should be pretty routine at solving these by now. So 3t cubed on 12 minus 5t squared on 2 plus 15t plus c. Remember that I know s of 0 equals 0. So 0 equals whatever this is with all the zeros subbed in. And you might want to just skip to the fact that c equals 0. It's always good to get in the habit of substituting in, okay, so that sometimes you're not given the initial condition. Sometimes you'll give an s of 1 equals 15, and you'll know, oh, I need to sub in 1 everywhere. Okay, so my displacement function will be all of this with a 0 where c is. This 3t cubed on 12, I'm going to change to t cubed on 4, just to make it a bit simpler. Okay, so I've finally found my displacement function, and now I can sub in to find s of 5. Sub in t equals 5. S of 5 is 5 cubed on 4 minus 5 times 5 squared on 2 plus 15 times 5. Okay, so calculator time from here. Cubed on 4, correction, subtract 5 times 5 squared on 2 plus 15 times 5 equals 43.75. So I'd write some statement like the particle is 43.75 meters away after 5 minutes. Okay, so from here you should probably turn the page over, have a go at these questions. Okay, where you need to find either find V, find S again, or just practice some integration for some reason. And there's a whole heap of answers there. I found one that's wrong already. There's probably a heap more. Alright, good luck.